continuity. So if a graph has, well, no breaks basically is what I'm saying there. If there's no breaks in the curve, so there's no vertical asymptotes, point discontinuities, any other gaps in the domain or range, we say that curve is continuous. It just continues on. So what do discontinuous graphs look like? Well, there's a classic one, the hyperbola, of course. We've got a couple of asymptotes there. X over x, which we're saying that when we draw it, sure, it looks like the line y equals 1, but has a point discontinuity at the y-axis there. So it's not continuous. Oh, these sorts of graphs where it's split into two different functions depending on the x values. So that's not continuous. So why is that important? Because that brings up this idea of differentiability. Now, in order to be able to differentiate a curve, it has to be what we call smooth continuous. So yes, it has to be continuous, but also smooth. The tangent also can't be vertical at that point. So something like the absolute value curve, yeah, that's continuous, no question about it. But it's not smooth continuous, because it's got a sharp point. So that particular curve, we say, yeah, we can differentiate it everywhere except x equals 1. Because depending on how we look at it, we'll get two different answers for the slope. Are we looking at the left-hand side of the graph, or are we looking at the right-hand side of the graph? So we say it's not differentiable at that sharp point. There's one with a vertical tangent, so a parabola on its side. Yes, again, it is continuous. And I suppose it looks like it's smooth continuous, which is why we have that second point there in the definition, because if that is a vertical tangent, well, what does that mean? It means the slope is infinite, if you like, and the derivative, therefore, would be undefined. So you can't differentiate at that particular point. And then we have this sort of shape, which is what we call a cusp. But again, it's continuous, but comes down to a sharp point. And in fact, that would have a vertical tangent, if you look at it. So that one couldn't be differentiated at x equals 2. So that's what we call differentiability. Now, how do we get two exercises out of that, you ask, eh? But there you go.